Hello everyone and welcome to the next section which we're looking at, which is networking in retrofit. So as you can see there from the different cards, I've broken it down as follows. So we'll initially talk a little bit about the web service that you're going to be, and the RESTful API that you're going to be accessing, which is a Node web server that I've built for the purposes of this lab and what will be the next lab. Okay. We will then look at kind of networking in general and the retrofit approach, possibly looking at some simple examples and trying to give you an idea of where to start and taking a simple GET request from start to finish in terms of implementing and utilizing the retrofit library. And then we finally finish off, as always, with a code walkthrough of the next version of Donation, which uses this retrofit library so that you get some idea of how you can connect to a RESTful API with an Android app. Okay, and in the lab there we'll bring it all together for you hopefully, and you get a better understanding and maybe even decide to use it yourself in your assignment or in some other projects that you may be working on. Okay, so I will hand you over now to that first section, which is that Donation web service talk. So hopefully you enjoy it, and other than that, bye bye. Okay, so hello again, and what I want to look at today is a Donation web server, which I've built for the purposes of the lab that we'll be working on, and that lab K08. Okay, and what the purpose of it is to continue on with our Donation web app and connect to this Node server web app, and this is where from now on we will for the next couple of labs anyway, we will maintain our list of donations where we can, when we make a donation, it'll get posted up to the server. Likewise, we will carry out a GET to retrieve them all, and it'll be done using retrofit. So in the lab, we'll be working through retrofit and embedding retrofit into our Android app Donation. But what I want to just look at today is the server side of it, the type of JSON that you would be kind of retrieving in the request, the retrofit request, and then more importantly for us, I suppose, how retrofit looks after and Google's JSON looks after the conversion of that JSON to and from when we're posting up or retrieving down. Okay. Hopefully I think this is we're starting to get a bit interesting there now. Hopefully you'll find that too. So like I say, I just run through a brief overview of the web server. Okay. So to just talk a little bit about it, what it is: manages our donations made to Homer's presidential campaign. What are the features? It's all RESTful, so you would have kind of done some of this stuff before in previous kind of web modules, where we can post a payment type of donation, and we're going to modify our model slightly, our donation model, and bring in a message field just to make it have a little bit extra that we can work with. We'll be able to get a list of those donations, so we can then display those on the report screen. We can get an individual donation for either deleting or editing, and again we'll get to that later in the lab. And we can also delete an individual donation. There's an option there for upvoting. That's kind of tied to the server side, because I would have been using it to something like this server in another module I would have been delivering. And I suppose just a kind of bit of background, persistence is using Mongo, and it's deployed to Heroku. Okay, so we have our Node web app deployed to Heroku with a Mongo backend. Okay. In terms of the endpoints or the routes, right? So what we have is we just use our screen brush there for a second. Hang on now, just check the color. There we go. So we have our /donations, right, which will kind of invokes a function on the server to find them all. We have this to get our total votes, but again we won't be kind of using that just yet. What we will be using is the ones I have in bold. So we will be using this when we want to find one, sending up an ID. We can then add a particular donation, so we will post up, and we will use retrofit to take that basic donation data, convert it to the JSON, and that gets posted up. And we can use Postman. And we'll talk about that later on. With that, Postman is a nice little client to kind of separately test endpoints, and we'll use that at some stage in the lab. We can do an edit, okay, kind of a brute force edit. We'll just push up everything again, but that's fine, it'll be okay just for the purposes of the lab. And we'll be able to delete an individual element as well. So what I want to look at in the next few slides is just the JSON that you would be working with, so that you have an idea of when you need to test this manually, during the lab, you kind of have an idea what you're working with. Okay, so if we have our get or find all, this is the kind of donation at the moment. When I ran this one here, just a dummy set of data, we've 3 donations up there. There's our Mongo ID we're getting back. That happens to be MLabs, that's where it's deployed. There's our our payment type, our amount, and we have a kind of a dummy message sitting in there. And again, just notice it's inside an array of donation objects. So that's what we're sending back, and that's what you will be retrieving from the server. And that's what retrofit needs to know about. So again, that stuff we will cover in the lab and some of the lectures as well. Okay, so I'll talk about that in more detail when we get to it. In terms of our find one, again, we would just be looking up a particular ID, this one here. So we would put it in the request that we're looking for, and that would send us back. Now, it's still worth noting, it's still a JSON array, but it just has one element. So that's, we kind of need to know that in terms of what we're retrieving back. Okay, and the rest of them are all kind of similar. If we look at our adding, this is all we need to post up. Okay, so if the request headers, they'll have to be our application JSON will be one of the request headers. So again, I'll talk about that in the lab when we get to it. But the plan would be, when we get to the stage of I'll build in a swipe refresh on the report, so that if, and it can happen quite often, if our data happens to change while we're using the app, we can simply swipe on our list and refresh that list automatically. So how we can test that is using Postman, and mid-app, looking at the report, we can actually manually use Postman to add a new one, and then we can do a little refresh on our list and we will see that added. So this is what you'll need to be posting up just to test that. Look, you could, if you wanted to work in teams and someone could add one and a student could do a refresh for that, that's an alternative way, an alternative thing you could look at. But if you want to do it manually or outside of work or whatever, we'll use Postman to do that. Okay, in terms of then our this is just a note as well. When we do add, this is what we get back. Okay, I'm just sending back in the JSON request a message, and then wrapped up in a data object the donation that we would have added. So if you see it there, we added 1, 2, 3, 4. There it is, there coming back the amount 1, 2, 3, 4 and a payment type of PayPal. That's just tied to the server. We probably don't need to use this at all, the data section, but it is important to let retrofit know again the type of message that's coming back. Okay, and that will be covered in the labs. Okay, in terms of this is just if we do an add again, just to confirm. If we do our get again for all our donations, we can see the full list. So there's our one just added in at the end there, that with the amount of 1, 2, 3, 4. In terms of editing, so we would have to find or grab the ID that we want to edit. So what I'm doing, I'm going to edit the one we just added, which is the really one last test, and change the amount to 1, 2, 3. And it's a put request, obviously. Okay, headers would need to be the same. So when we execute that, this is what we get back. There's our message again, just saying donation successfully updated. And in the data, you can see it there. There's the payment type amount, a new changed amount, and the existing message. So again, like I said, it's a brute force update. Just we to update all the fields again. It's nice. It keeps it nice and simple, easy enough to implement when we get to it. Okay. A delete, very similar. We just grab the ID and then we execute a delete on our server with the particular endpoint. And when we picked up the one we want to delete, we would have identified this ID. We just get a simple message back. Donation successfully deleted. So in the labs, what we will do is we'll eventually kind of add in a delete button on our cards that are on in the recycler view, so that we could individually delete the elements. So we kind of be sending up this ID, and that's what that's how we'll delete it from our list. Okay, that's the full endpoint or the full web address for the server where it's deployed to on Heroku. Because this is free and it's a very small web app, when you're testing this, I would recommend just hitting that first, okay? Just to wake up the server, so that you get something like this. So when you just go into a web browser, throw that in, access that page, it'll load up the website. It might take a couple of seconds to load up, but once it is woken up and it is live, when you go and test your application, it'll run a lot quicker. Okay, so that's just as a little kind of FYI, just quick wake up as a server, so you won't be waiting too much to test it from then on. Okay. Other than that, I think that's it. Just talking about our server. So until then, thanks for listening, and goodbye. Hello everyone, and welcome to today's topic, which is networking with retrofit. So what we're going to look at today is basically this nice Android networking library. It's actually written in Java, but we can use it in Kotlin as well, to allow us to connect to the API that I talked about in the previous section. So what we're going to do is we're going to refactor our donation app again, and where previously we're working with like local data, we're now going to, with the use of retrofit, connect to this remote web server. Okay, so in this section, what I want to just kind of talk about and run through with you is the following. So we'll just have a general networking overview, just to again put things in context again. We'll talk a little bit about the annotations and classes that we need to use and utilize to get this off the ground. We will revisit interfaces a little bit, because it is important in terms of how we get to implement and integrate retrofit. And then finally, we look at how we actually do integrate retrofit into our Android app. Okay. So quick overview. So in a nutshell, excuse me, Android networking, right, or any networking for that matter, works with the following. So if you've done any web development before, you should be familiar with this request response approach. But if you're not, it basically boils down to the following, right? You have this notion of a request, right, which is when you make a HTTP request to URL called your endpoint, with proper headers if you need them, and generally with some authorization key if required. Now, we won't be doing any authorization in this particular version. We might do some later on when we look at Firebase, but for the moment, it'll be just kind of standard requests that we're going to make. So the request is from from the client side, so from the Android app to our a web app, right? So we'll be kind of the term is we'll be hitting that particular endpoint. So those endpoints I was talking about in the previous section, they're the endpoints that we're going to be making requests upon, okay? The other side of that is the response. So the request will return a response, which can be, it can either succeed or not, so you get back an error or success, right? When it does work, when it is successful, the response will contain the contents of the endpoint, generally in a JSON format. It doesn't have to be JSON, could be HTML, could be flat text. In years gone by, XML kind of was the standard approach, but now JSON is seen as the kind of the de facto standard for working with APIs and kind of sending data across the web. So what we're going to do is we're going to be making requests on those endpoints. The response that we get back from that request will be in a JSON format and will be either an individual donation, a list of donations, or a kind of a message to say, yes, our update was successful, or yes, our delete was successful, or so something along those lines, okay? And so that's the kind of the request response pair, okay? To finish off, the last part of the whole kind of process is this notion of parsing and storing. So we parse and store. So this will parse the JSON and get the required values and store them in our data class. So in theory, what happens is you get back the JSON format from a request, which the most basic one is a GET request, and we talk about those now later on. And then we somehow have to convert that JSON object into the type of object that we need. So in the case of our particular example or donation, it'll be a donation model that we need to convert that JSON into. So in this section, what we're going to look at is all those pieces, all those little components that we need to actually make that happen. And at the end of the section and in the code walkthrough, we look at how we do a little bit more. And I mentioned it in this particular set of slides as well. There's a lot more you can do than just a simple request. So we look at that kind of that whole CRUD approach and how we can add stuff, or the term will be post up information, how we can retrieve, delete, get, and so on and so forth. Okay. So just to kind of talk about a little bit of overview, again, of the kind of networking and the approaches that we can take. So in Android, we can use any of the following for executing our kind of HTTP calls. Okay, so the first one there is OK HTTP. We can use this for creating HTTP request with all the proper headers, but this is pretty low level stuff. Okay, so as we'll talk about again later on, retrofit sits on top of this to try and make it a little bit easier, a little bit more straightforward to use. Okay, as I said, the second one there, which is what we're going to use, is retrofit for making our requests. We can use Moshi or JSON, which is a nice again other library by Google for converting JSON into a Kotlin Java object or vice versa. So this is what we're going to use to make those conversions. Okay, and again we look at examples later on. We could use Kotlin coroutines, right, for making non-blocking or on the main thread network requests, and you can also use the likes of Picasso or Glide for downloading an image from the internet and setting it to an image view. So we will kind of look at this. We might actually mix and match between the two. I know I have Glide highlighted there, but if memory serves, I think I kind of we make use of Picasso as well. But again, very straightforward libraries for doing what is essentially quite a lot of work in terms of downloading an image, rendering the image correctly into whatever widget, generally an image view on your layout. Okay, so it's all very useful. If we look at the official kind of retrofit docs, okay, so again, still says it's a type safe HTTP client for Android and Java. So this is kind of a first look at the kind of code that we will be working with. So initially, what we will start with is some kind of an interface. So we're going to come up with our own interface. Again, this is kind of Java based, but we'll be converting into Kotlin. What I want to highlight for you at the moment is this here, this annotation. So what we will do is we will be annotating our kind of local calls. We will modify our existing donation store interface to deal with the type of request that we want. So at the very basic, the kind of the most simplest request is a simple GET request. So what this is saying, we want to access the endpoint users slash, and there's a user element been passed in as a parameter, and slash repos, and then that's that user there that's been passed in another annotation path, so that when we make a call, we will pass in a user parameter, which in this example here has been specified as a simple string. Now, once we have retrofit configured correctly, that's all actually looked after for us, and that's why the retrofit library is a really nice, very popular library for allowing you to connect to a RESTful API, connect your kind of web app endpoints in an Android app. Okay, something else we'll be looking at as well is generating an implementation of that particular interface. So we will kind of pass in a base URL, maybe some other elements as well. This is the most basic approach to building up that implementation. So there's a lot of other parameters and kind of configuration settings we can change, which we look at some examples as well. And then with that service, when we've got our service there, something along those lines, we'll see this our retro. So we would create or build the retrofit kind of configuration. We would use that to create, based on our interface, an implementation of our interface, should I say, an instance of that service. In this example here, it's called GitHub service. So there's the service element, and then somewhere in our code, we can say the service dot, and there's that list repo. So that ties back to this interface function up here. passing in a parameter here. So this, in this instance here, this would be the username, and that gives us back then, in the context of this call, a list of repo objects. And all that conversion is done for us behind the scenes once we configure it correctly. Okay, so that's again just another reason why we're going to kind of use this approach. Okay, so just to talk a bit about a little bit of detail. So what is it? It's a Java library that turns your REST API into a Java, or in our case, Kotlin interface. It simplifies HTTP communication through declarative and type-safe interfaces. So again, we'll look at examples of that later on. It's developed by Square. The guy behind Square is Jake Warden. It's one of the most popular HTTP client libraries at the moment for Android as a result of its simplicity and its great performance compared to others. Again, we look at this now and have on the next slide some kind of comparison figures. And final point there, it makes use of the OK HTTP from the same developer in Square there to handle network requests. So prior to retrofit, you could have still used OK HTTP, but there would have been a lot of extra work that you would have had to do, some quite low level working with streams and setting up those streams and all the rest of it. So using retrofit is a very straightforward, streamlined approach to networking if you need to bring in networking. Again, I suppose we will be moving on to Firebase at a later point. The reason we're looking at this particular topic is, what if there's a situation where you don't have access to, like you will have in the labs, you don't have access to the server. You know what the endpoints are, but you can't get in at the raw data behind the scenes. You don't have access to the back-end database like you will have with Firebase. So when we work at on the Firebase side of things, you will have a lot more scope. So if things need to be changed, you can do that. But a lot of the time, as a developer, you only have access to the endpoint. So you can only work with the data that you're given. So retrofit allows for a lot of configuration, a lot of adaptability when looking at retrieving information from possibly a third-party service. Okay, so again, that's what we're going to look at in this section. So just some comparisons. So again, just a couple there. We've got. Hang on, sorry, where am I going? There I am. So we have our async task, our volley, and our retrofit. So again, volley is another Google library for networking, but as we see it here, the async task has been around a while now, but these are kind of what would be the three most common approaches that you could use for networking. Okay, sorry, I'm going to have to hide myself there now, sorry. Bring myself back, there I am. Okay, so if we look at kind of one discussion, or kind of roughly one request, I know it's milliseconds, right? But if you consider the fact that there could be tens of thousands of requests been made over a short period of time, and on a daily, monthly, yearly basis. So the last thing you want is for delays in those particular requests. So if we look at the async task 941 versus 560 versus the 312, so the retrofit is 3 times as fast as if you were making a sync task, asynchronous calls. Okay, if we look at it, jumps up a little bit more. If there was 7 requests made potentially, there's our comparisons. And if we look at then 25 kind of requests all bundled closely together, there's a massive difference between our retrofit and kind of the async task approach, and even with volley, there you're looking at like over 4 times as fast. So it mightn't seem a lot when we're dealing with like milliseconds there, but as the requests build up, and then you have multiple requests been made on a server and multiple users using your app, it can all these kind of these figures all kind of these time delays all kind of tot up, So if we continue on, so why use it? Okay, so kind of touched on this before, but this is one of the main reasons, right, why you would want to use the likes of Retrofit or even Volley if you choose to. Developing your own type-safe HTTP library to interface with a REST API can be a burden. You have to handle many functionalities such as making connections, caching, retrying failed requests, threading, response parsing, error handling, and a lot more. And that would have been the case if you were writing your async task. So again, that you it's the raw Java, raw Kotlin code. Okay. With Retrofit, it's very well planned, very well documented, and very well tested. So kind of taken from their official docs, it's a battle tested library that will save you a lot of precious time and headaches. And I hope you will see that when you go to work through the labs yourself, and possibly maybe you do some little bit of research on your own and looking at, and you might want to bring this into your assignment. If you already have an existing RESTful API up and running and you don't want to go down the Firebase route, this is an alternative approach to implementing some kind of cloud-based service into your application. Okay, so if we have a look at the basics. So kind of where do we start with it? Okay, so Retrofit is a flexible library that uses annotated interfaces to create those REST calls. That's the important bit there. There will be a lot of annotations that we need to use to utilize this library. Okay, so if we look at our own example here first, right? This is our kind of existing data class, and this is a very nice example of how Retrofit quite easily can allow you to maybe work with data that doesn't match exactly to your own data class, for example, right? So it makes it a lot easier if the fields match. So the fields that are your object stored up on the server in the backend database, and the fields that you're working with in your object inside your Android app, but they don't have to. And here's a simple example here. So in our model, we're working at the moment with a payment method. Okay, now up on the server, as you would have seen in the previous section, the equivalent is called payment type. Okay, so rather than we having to pull down payment type, modify it, copy it over to payment method, and do some checks and all the rest of it, we can just use a simple annotation in our class saying @serialized name, passing in the name from the server, and that will automatically map payment type to payment method, and that's all we need to do. So it's very kind of useful. Okay, so this is kind of like where we're starting. So this is the model that we are going to that's represent the data, and ultimately, I suppose, the JSON object that we're going to retrieve from the server. So what we're going to start with is looking at a simple GET request and follow from start to finish how we would implement that GET from our basic data class model here through to the interface, through to the implementation, and the usage then within our Android app. Okay, so we would start with the interface. So again, once we define the class, we can make a service interface to handle our API. A GET request to load all donations could look something like this. So if we see it here, so we're going to work off our interface that we interface donation service, right? Here we have a simple, these kind of go together now. So for each function that you're going to have, you will have a corresponding annotation to say what and identify the endpoint that you want to hit. Note, this is just an endpoint. It's a relative point. We're not explicitly specifying the server name. And again, that's the general approach and the recommended approach to take, so that very easily we can change the server name and not affect our interface and any of the endpoints that we're going to be accessing. And that's what we will actually do in the next couple of labs. So the first lab will be just simple, a kind of single user. The next lab will be a multi-user approach. So we will need to modify the server and access a different server, which will simply involve changing a URL. Okay, so for the moment, we're going to say our annotation there, we're going to call it an @get, so our endpoint is going to be /donations, and the function that we're going to be implementing we're going to call it getAll, and it's going to return a call object. We'll talk about that in a little bit more detail, which is going to return a list of donation model objects. Now that's going to come back in basic JSON, right? But we will, using Google's JSON, automatically convert that JSON data into a list of donation models, and again, it's all done within like 1 or 2 lines of code. It's very, very nice. Okay, just a last point there. Note that the @get annotation takes the endpoint we wish to access. As you can see, an implementation of this interface will return a call object containing a list of donations, like I said. Okay, so that's that's where you start with your interface, specifying the functions with the corresponding annotations and specifying the type. So at get, there's a full list at the end of the slides, but we could have an @post, we could have an @push, an @delete, a lot of them in there. Okay, so the next step is the coming up with kind of like the implementation, or the building up and getting an instance of that, an implementation of that service. Right, so the way we're going to do it is as follows. We're going to create a little singleton object, say object donation client. Okay, here's our URL. So this is what we can change later on. Okay, so at the moment it's a donation web-http server up on Heroku. Okay, so but it doesn't have to be. This could be any URL, any web server that is exposing some a RESTful API for you. Okay, so what we're going to have one function, our get API, it's just highlighted there for you. Okay, which is going to return a donation service element. So this is similar to what I would have covered in the slides previously, in kind of the basic examples of what we would have seen up on the official site. The retrofit site. Here we are using our JSON builder, so we're going to identify that we want to use Google's JSON. This is all part of the library as well, which is really nice. We're going to use Google's JSON for parsing. Okay, here we are creating our OKHTTP client, which kind of sets some communication timeout. So here we're saying that if it doesn't connect after 30 seconds, we can time out. If the write doesn't go through, if the read doesn't go through after 30 seconds, we can just cancel the request. Okay, so that's quite nice as well. You can change those. You can maybe modify those if you find maybe that your connection isn't that great. And then finally, we create and build up the interface. Okay, so here we are specifying some properties. Here we are setting the base URL, so our service URL ties back to this one up here. So ultimately, what we're going to do is we're going to be accessing, for our simple GET request, we're going to be accessing this /donation. So that will be the full explicit, fully qualified kind of request that you're making. So, but it always makes sense to keep the URL separate from the request that you're going to be making, so that there's minimal changes that you need to make if the server changes. Okay, here we are. So that was the base URL. Okay, here we are adding the converter factory. So again, all parts of the library as well, once we've included the particular dependencies for Google's JSON. So we have our JSON converter library.create, passing in JSON as the reference up here. So that's basically saying that we want to convert all our JSON objects back into what ultimately will be a Kotlin object. We have our client here, so specifying then again the communication stuff, our OKHTTP client, and then finally .build to actually create it and return an instance of it. So then when we can return that API, that instance, .create, and there's our donation service interface that we would have previously modified. Now, the great thing is when we go back and add in some extra functions into the interface, once we build up the project again, that will all then be generated for us as well. Okay, so there's not a huge amount of extra changes we need to make as we go back and modify our interface. Okay, just to talk a little bit about the call, that call object. Just one of the most important point really from our perspective is this one here. It models a single request / response pair. So ideally, if you just have one activity, one fragment that's doing one job, Okay, so maybe it's our donate, and that's just going to request, it's going to have a post request, going to send up the data, hopefully get back a response saying that the donation was added correctly. In that instance, the activity or the fragment can directly implement the interface and then generate the corresponding request response on response on failure functions that we will see examples of now soon. The issue arises if you want to make more than one call inside an activity or inside a fragment. In that instance, and there is a flexibility there, it's a little bit more complicated, but you have to create anonymous classes so that, for example, with your if we extrapolate out the donate a little bit more, and we have the donate and we need the total, so we donate an object, make a donation, post up the donation, but we now need to keep track of the total as well. So that would involve a get request. So there's two different requests going on there. In that instance, we would probably need to work with anonymous classes, which we will again look at later on as well. So that's kind of the first point to note about that call class. Okay, it separates the request creation from response handling. Again, we'll look at examples of this later on. It keeps it nice and tidy, nice and separated out, so we can keep all our code, the necessary code, all bundled up inside one dedicated function. Another point there: each instance can only be used once, right? But they can be cloned. Okay, so that's kind of worth noting as well. Also supports synchronous and asynchronous execution. Okay, so if you feel that the calls might be taking quite a long time, maybe you're wanting to download a video or something, you could run it asynchronously, but it supports asynchronous calls as well, and can actually be cancelled. In previous versions, there would have been issues with even the whole KHTTP and other libraries that may not cancel when expected. Okay, but this as far as retrofit is concerned, that actually they can be cancelled. Okay, so if we go ahead now and look at how we can call the API and actually use it now inside our donation app. So we look at a little bit more detail now into how we call the API. So how do we use this interface to make requests to the API? Okay, we use the retrofit to create an implementation of the above interface and then call the desired method. So again, we'll be looking back to our interface. What functions have we in there? The kind of the example we're looking at the moment is that get all. Okay, so we will kind of trace through that get all, how we implement the interface, the generated functions, and then the code that we will put inside those functions to get the desired result of that list of donations that we've just pulled down from the server. Okay, just another point there. It supports a number of converters used to map Java and Kotlin objects to the data format your server expects. So in our example, it's JSON, but it mightn't be. And again, this goes back to, from the developer's perspective, needing to know the type of data that you're getting back from the server. Okay, and you can see there's some of them there now. So you can see, look, there's JSON, there's Jackson again, Moshi, right? These are all kind of working with JSON. Look, protobuf is one there, wire. There's, if it happens to be XML, simple XML, right? It's even one there for scalars. Look, all primitive stuff. Okay, but we will be focusing on JSON in the lab. Okay, and we could look at it in the notes as well here, obviously. So if we look at our interface for the moment, right, we're going to modify it slightly, right? So the interface, where we have a find all here, right? So we're going to now retrieve, or what we will pass to it will be a mutable live data list. Okay, and we will go off and we will see some of these eventually when we go and implement the full retrofit implementation in the labs. But for the moment, we're just going to kind of focus on finding or getting all the donations to get that list from the server. Okay, so slight change to our interface. Inside our manager, what we're going to do is as follows. Okay, so we see it here. So again, our manager still implementing the donation store interface. Okay, we still have our donations, our raw or donations list, but inside our find all function, this is what we have now at the moment. Okay, we create an instance of our call element, our calling on the donation client. So we call donation client.getAPI.getAll. So this is we're chaining a couple of calls here. So this is going to generate our instance and invoke the .getAll. And because we're inside the function here, here's an example, and it's kind of useful putting it in this instance here because it's inside our manager. As I talked about previously, here's our anonymous object that we're passing in. We obviously can't pass in a reference to this because we're not inside our an activity, or we're not inside a fragment, and we want to keep to the principle of our MVVM. So we need to separate out where we're getting the data so that we can pass it off to our some kind of our view model. Okay, so here we have we say call.onQ. We're passing in an anonymous callback object. So this callback gives us this on response and on failure implementation. So this is expecting, and this will get back, if it's successful, a donation model list. If not, it will get back a throwable, and that will give us an error. Okay, so for every callback implementation that we have and the type we get back, we would have either our on response or our on failure. If it is successful, the on response gets triggered, right? Which in turn, these are the parameters. So when we implement it, these are the parameters we get passed in. It gets the call object and it gets a response object, and it's the response object will hold that data for us. So what we do then on a successful call is we update again. Remember now, what's the dot value? That's our list. We say donations list, which is the mutable live data that we just passed in up here. There it is up there. It's raw data, raw donations property. Its value list is assigned, and this is the key here, response.body. So because we have specified in our retrofit builder that we want Google's JSON to do the conversions, when we say response.body, that will automatically take the JSON, convert the JSON into the type of response that we expect, which is a donation model list. We will convert it to and store it as an array list. So we use our as array list donation model, and then assign it directly to our mutable data, which is our live data, which is our donation list, which will then trigger an update back in the view. All right. And then we just have a simple Timber call there. This is more for the developer's point of view, I suppose, developer's perspective. We just display that to the end user. Okay. Otherwise, we get a failure, and we you might, if you wanted to, you might want to display and or pass an error, a message back to the view to say that something went wrong. From our perspective, we just it will kind of cancel out. Okay, but that's the key here. We say we create our call instance with our .get call. We can say on the call object .onQ, passing in our anonymous callback, which gives us the on response and on failure implementations, the function that will get triggered either on a successful call or on an unsuccessful call. Okay, so just to talk a little bit about it in a bit more detail, back in our report view model, we actually trigger that update, and which will, as I say, will cause the view to auto update. So now in our report view model, which is tying back again, this is our list, we still trigger our load. Inside our load now, we are now calling our donation manager.findAll, passing in that mutable list, which in turn goes off, makes the retrofit call, pulls down the JSON, converts it, stores it in our mutable live data, and triggers the update. Okay. So just to look at it in a little bit more detail. Okay, so the on response, just a couple of points, just to kind of, I've mentioned it already, but just to be complete about it. This is triggered on a successful call to your API, takes your two parameters, which is a call object and the expected response. So you have to specify what that response is, and that will be generated out of the interface. Okay, and the converted JSON result is stored in that response.body. Okay, so we just do that little as array list just to convert it, and just be clear about the type that we are assigning to our .value property of our mutable live data. Okay, so that's when it works. It's successful. On failure, right, triggered, as I said, on an unsuccessful call, takes two parameters, again a call and a throwable, and you can examine that throwable object to get some extra information about what might have happened. So you could either dump it out into some maybe kind of an error log. You could maybe even display it back to the user, and then they could maybe pass that on to you. Okay. Now, as I mentioned earlier, you're not limited to just get updates. Okay. So what you can use are a lot more. So in our example here, so this is our kind of a refactored interface. So as well as our get for all donations, we now have a get passing in an ID as a parameter, our function get, which will get an individual donation. So again, note, it's a call. This is a list of donation. This is an individual donation. Note here, we're now using a donation wrapper, right, instead of the raw donation model. This is because for the likes of delete and post, right, and a push, okay, we want to get back some kind of message to confirm that yes, our delete, our add, and our edit were successful, or possibly not. Okay, so again, this is another version of a donation service, and all we need to make sure is that we use the appropriate at get, at delete, at post, and anytime there's parameters, you just wrap them up in curly braces, and that parameter needs to be passed in as a parameter into the function, also annotated with the at path there as well, to say, look, in this case it's an ID, which in this case is a string. Here we are for our post. In the body, again, more annotations. So in the body of the post that we're sending up to the server, it's a whole donation that we're passing in. Again, this will all be covered in the labs, and we cover this in the code walkthrough as well. Okay. So if we look at some other examples there, some dealing with headers, right? So we won't be looking at too many of these, but just for completeness, if you need to specify some headers and headers are required in any post or any request that you're making on that third-party API, this is how you do it. So if you wish to add headers to your calls, you can annotate your method or arguments to indicate this. For instance, if we wanted to add a content type and a user's authentication token, we could do something like this. So here what we're saying is explicitly we're sending up JSON in our request, and we're also, as well as the body sending a donation, we're also specifying some authorization token, so that if there was you were dealing with web tokens and you needed to authorize and they need to be authorized access to allow the post to happen, that's how you would do it. Okay, some other points to note as well. Bridging the gap between your code and your API. We touched on this in early on in the section, but dealing sometimes, and this happens quite a lot, variable names might change. Okay, so for example, if you use a Rails server, you'll probably be returning data using snake case, while your Java Kotlin probably uses camel case. So how do you kind of deal with those discrepancies between the field names and allow then the correct mapping and allow retrofit to make that mapping for you, right? To do that, you simply use your @serialize, right? So what we're saying here is up on the server, the field is called date_created, but inside our model, it's called date created with the capital C there. Of type date, and that's all you need to do inside your model on your client, essentially on your in your Android app. Okay. Some other points to note as well, very nice as well. We have you can also create your models automatically from your JSON response data by leveraging a useful Android Studio plugin, which is the JSON to Kotlin class, right? So for argument's sake, we say you're starting from scratch and the project is you have beforehand, before you start, you know what the API is, you know what the endpoints are. So rather than going off and manually building up the object and working with the different objects and the type of data that you could be pulling down, you can use this nice little plugin to auto generate and mirror the model of the data that's stored on the server. Okay, so what you would do is you go into your plugins, you can see it there, and you search for, I think I have it on the next slide, let me see, do I have it there? Yeah, if you just type in JSON up there, see it up there, JSON there, the first one that'll pop up is that JSON to Kotlin class. So you just go and install that. If you run Option K for a shortcut, right, you can dump in the JSON. So you could make a simple GET request through the web server, through something like Postman if you wanted to use that. Grab the JSON, dump it into using your Option K there to generate the Kotlin data class. So you'll paste it in there, give it a class name. I think you could have it on the next slide there. I do, yeah. Give it a class name. So in this case, just calling it donation. And what you get when you click on generate is something like this. So there we have our _ID, the field names, and then the types will all match, which is really good. Okay. Another one just to talk about as well is your date formats. This can be an issue as well. So another potential disconnect between the app and the server is the way they represent date objects. So for instance, Rails may send, again, come back to Rails again, may send a date to your app in the format, the YYY, MM, and the DD, and then there's your hours, minutes, and seconds, right? Which JSON will not be able to convert to a date type. So we have to explicitly tell the converter how to perform this conversion, okay? So in this case, we can alter the JSON builder call to look something like this. So where initially we just had JSON builder.create, you can now say JSON builder.set date format and tell it the type of format that's coming down off the server. And again, all the conversions will be done automatically for you. It's a really, really nice library to work with, and I definitely recommend it if you need to build some kind of cloud-based project. You want to have some back-end, there's some back-end servers there, and more often than not, you don't have access to that back-end server. Okay, we will move away from this, as I say later on. We're working with Firebase, but for the moment, we're looking at if you don't have access to that. The server side, and all you have access to are the endpoints excuse me, to get at the data. Okay, so just to finish off, there is a full list of all the annotations. Okay, so if you if you need to, you can investigate those in a little bit more detail. As always, any questions, there's some references for you there, so any questions, any issues, you can get me over Slack or on email. And the next section now, we kind of look at a bit of a walkthrough and look at the specifics of that retrofit implementation in our donation app. Okay, so other than that, thanks for listening, and goodbye. Hello everyone, and welcome to our the next code walkthrough, which is our version 4. So this version has the retrofit implementation in it. We won't obviously look at everything, but we kind of look at the most important bits and where kind of we've implemented retrofit. Okay, so if we, again, just a quick aside, I suppose, and just looking at the service itself. Okay, so just to remind ourselves what we can use the donation service for, right? For adding, updating, and deleting a donation, for listing all donations, and for finding a single donation. And these were the paths that we will be using. So /donation, and again, this is on the server side. This it doesn't really affect you that much, really. But this will be the JavaScript that's getting triggered on the server side. So all you're concerned about is using the correct endpoint /donations to, and then behind the scenes triggers the correct function. And so depending on whether it's a get or a post or a put or delete will determine what type of JSON object is returned back. So in this one here, as you can see, the message is saying donation successfully added. This is what will be generated from a successful post, so that we get the message and we get back then the object that we just that we would have added. And you can see this ID here, _ID, it's a string. This is tying back to a Mongo database. So that's the kind of the ID that Mongo would generate for. But again, not too much of a concern from the developer's point of view, just being aware that it's a string and not kind of a number, okay, in terms of if you're doing or finds and updates and all the rest of it, okay. So once you're kind of familiar with the endpoints, you can then go off and implement and use retrofit to write your application to access that endpoint, okay. So the steps, while I go through the steps to integrate retrofit into your app would be as follows. So first of all, set up your project dependencies and any permissions that you need. We'll look at that now in the next slide. Create your interface for the API and declare methods for each REST call, specifying the method type using these annotations. So is it an @get, an @post, an @put, for all the rest of them? If we're working with parameters, we'd have to use @path, @query, or @body. So again, we're going to see most of those. We would have seen some examples, but here we'll see it now actually in the project itself within donation. We would use retrofit to build the service client, and then finally go off and make those calls as we need them using the relevant callback mechanism. So we would have looked at the examples of this in the previous section. We're now going to look at how it's actually done within donation, okay, and the current version. So to begin with, here's our dependencies. You can see them here. There's our retrofit. So at the moment we're 2.9 and our JSON is 2.8.6. What it would do is when you're working through it and you bring them in from the lab, as always, if Android Studio is saying that that they need updating or that they're a little bit out of date, then maybe change them to what has been suggested. One little caveat though, I have noticed over the last while or so, sometimes if and when you do update to the latest version of whatever the dependency happens to be, it may cause complications and issues later on. So just remember what changes you make, that if you run your app again and you find something's not working or it's crashing, you might need to step back to that previous version. So just be careful of that, okay. And we also need then our permissions, because obviously we're accessing the internet, we're going outside the scope of the app itself, so we need permission to access the internet. So again, that would go in your manifest file and out before and outside that application tag. Okay, so the next thing was to go and create the interface and the wrapper as necessary. So again, I would take you through all this in the lab. So we would create a new package, our API package. Within it, the client, the service, and the wrapper. So here's the service itself. This is the interface. So I just highlighted there for you. Again, we kind of covered some of these back in the previous example again, but just looking at it now here again. So we have our get all. Again, I would just draw your attention to what's been returned. In this instance, because our gets are retrieving the raw data, we are retrieving either a list, a donation model list, or an individual donation model. Whereas with the @delete, @post, and @put, we want that message to confirm to the user that it worked okay. So we use and we retrieve the wrapper, because that does impact on the parsing that Google's JSON will do behind the scenes. Okay. In terms of the wrapper, right, this is what we have. So our wrapper class has a whole donation model in it, but also this simple message, and this is what would get generated on the server side and sent down with the response. So here, as I said, here it is. Here, there's our message and our data object. So this donation wrapper class corresponds to the JSON object that will be sent back in response to a post, a put, or a delete. Okay, so again, these will be just some of the these will be the requirements that you would need to follow as the client side developer. Okay, because you may not have access to the server side, you have no control over this. You just have to follow the structure and follow the class itself. And in this case, I'm just calling it a donation wrapper because we're wrapping up a message and then data that we're getting back. Okay. In terms of the client, very similar to before. There's our URL. This will change in the next version. So for the moment, this is kind of a single user app. So again, one major point to note here is that anyone who adds an element can see or an object, a donation, can see everyone else's donation, because it's just a single user request going on here at the moment. You can if you notice, there's no mention of a client ID or a user ID. Okay, the only IDs we're looking at the moment are the donation IDs. So in theory, someone could make a lot of donations, someone else could go and delete those same donations. So you could even, working through the labs, you could even work in pairs so that you could have a get and a post working, so that someone could post up and add a donation, and then someone else could retrieve and see that same that new updated list, but actually in a separate app on a separate device, just to prove the point that it is cloud based and we're retrieving from a server. Okay. In terms of the manager itself, just talking a little bit more detail about, we would have seen this in the example. So again, just looking over it again. So what we have to begin with is we would have modified this in our interface, and then so it's a mutable live data list, what's getting passed into find all. We then create our call object. So we're chaining our .get API with .get all. We then call .onQueue to add it to the queue of requests that retrofit will process when it can. And then here's our callback. So this is, and as I said before, this is an anonymous callback, and this allows for multiple calls in the same class. I would have explained this again back in the previous section, but this is very useful if we want to, as I say, have multiple different calls like we will have in our donation manager, and as we'll see now in a minute. In this version, it's it's the most straightforward one, I guess. All we're doing is retrieving a list of donations. So there's the response we get back, which is a list of donation model objects. We typecast, convert it to an array list just to make sure the types are equivalent, and store it in our mutable live data, which in turn back up the hierarchy will be updated in the view model, which in turn will update the view. Okay, and if anything goes wrong, there's our on failure. Okay, to look at some of the other functions that you would implement, there's a little bit more detail now. So in this one, for our create, which is essentially our add, our post, we're passing in an individual donation. So the user would have entered the details. We would have created that donation object and passed it to our donation manager. So again, this is all part of the lab. You'll be working through this. We're just looking at the kind of the retrofit relevant code here. So there's here we are creating the call, and again it's a .post this time because we're calling it post in the interface, passing in the donation, and here we are calling .onQueue again, but this time it's a donation wrapper that we're getting back. So to process that is a little bit different. So here we are, we're calling it a donation wrapper. So the body this time isn't a direct JSON object, it's the donation wrapper, which has, pardon the pun, wrapped up in it a message and the data. So here I am just showing you how to extract that if you need to. So we're just doing a check to make sure that the donation wrapper is not null, and I'm just using Timber and spitting it out to the log. But this, if you needed to, this is how you would get, if you wanted to, could get at the data property, and this is how you would get at the message property. Okay, and again, they have to go hand in hand, the on response with the on failure. Okay, both have to be implemented. Okay, so that was our on create. If we look at delete, something similar again. In this case, we're just passing in an ID, which is a string which we passed to the delete function of our interface, passing in the ID, which we then have our on the call itself, call it onQueue, with its own on response and on failure again, just making sure, just confirming that yes, we would have deleted correctly or otherwise. And again, just a message there if we didn't. Retrofit deleter. Okay, you can kind of see a pattern there with these functions. So these the lab will take you through all the kind of the extra little bit of work you need to do, and where these are called within the view model and ultimately back in the fragments. But again, I leave that for the labs for you to work through in your own time. Okay, just a few other things just to talk about some of the helper classes that we brought into this this version. Okay, so we wanted to implement this swipe to delete callback. So this is, I found this on GitHub. It's very nice. I think I have the reference in the lab itself and possibly in the solution as well. But basically what this whole class is responsible for is kind of setting and drawing the icon. Okay, setting the background color. So if you want, you could actually go in, if you want to go in and change this, you can, you're more than welcome to. Drawing the background color then as you swipe. So there's a lot of that you can see there. I've highlighted the methods. There's our, look, we have our on move or on child draw, so yeah, clearing the canvas, and then just some of the individual properties specifying. There's the my IC, that's the one I've added in. IC swipe delete, would have created that myself. You can modify these if you want to. I'd recommend not, because it's kind of, these are set to the size and the resolution of a mobile app. But if you want to experiment, please do. And you can see it there, just changing a color as well. So if you want to go in, you can change. Even if you want to change how it's swiped, we will do the same for a kind of a swipe to edit. So we will have two versions. We look at that in the next version of Android. But just kind of making note of what this particular class does and its purpose. Okay, so that was one of the kind of little helper bits. And one final thing just to look at, our swipe to refresh, because at the moment we don't kind of force an update in our list after we've made a request. So to allow the user to be able to swipe down on the recycler view, we just implement a set on refresh listener on the recycler view. Okay, so this will be, again, we'll be giving you this in the lab itself, but we just have a reload. The important bit for us is we just reload or load on the view model again, which will force a reload and force a new request, a new call to the server, pulling down the data, updating the list, updating the view model, which ultimately, because it's been observed, the live data ultimately updates the view itself in the recycler view. Okay, and just one last point there to note, just from debugging through it and testing it, you should also have this check swipe refresh in it, that if the swipe refresh is refreshing, you need to turn it off. So after the user swipes down and it starts refreshing, once it completes, you need to make sure that you turn it off again. So that's what we have a set swipe refresh and then a check swipe refresh. So make sure you kind of place those at the correct points within the calls that you're making, so that it operates as the user would expect. Okay, so what we end up with, something like this. So we have our donation app. So when the user will make a donation, or when they load it up, they get the list. So this list is coming from the server, and again, this list may be a lot of different donations made by a lot of different users. Okay, and unfortunately, because it's not multi-user yet, anyone could delete anyone else's donations. Okay, and again, our donation, so the information here, so when they choose our PayPal, choose an amount, or even type it in, once they hit donate, a post request is sent. So a post request will be made on the server. Once it's successful, we will make a GET request to make sure our total so far is also updated, to keep everything synchronized and again, what the user would expect. Okay, so hopefully you won't have any too much trouble with the lab, but as always, if you do, Slack and email are the ways to contact me, okay? But so other than that, I think that's the lot. Let me see. Yeah, that's it. So again, thanks for listening, and goodbye. Now, hello everyone, and I thought it was worth running through the solution to our retrofit example, just to give you a better idea of where the kind of the cause would need to go, just in case you run into a few problems while you're working through the lab, okay? So what we're looking at here is, this is the donation client, and you can see the URL I have highlighted there. So what I would suggest to begin with is actually access that URL, okay? So if we go to our web, right, and if I access that URL so far, just do a refresh again, right? What we're looking at here is I've gone to the slash donations endpoint. So if you can see here, we have an 83, a 996, 222, and a 321. Okay, so if we go back and we look at that in our report screen, 83, 996, 222, 321. So all the elements are there. Okay, so if I then go and add a donation, excuse me, here we just put 1,000 in there. Okay, direct, and do donate. Our total updates like so. Okay, we look at our report. Right, there it is down the bottom. Okay, but also if we do a refresh on the browser on the server, there is the 1,000 just gone in as well. So we're just confirming that our post works okay. And if you want to, the other feature we had built in was our slide to delete. So if I now drag that across, so you can drag it across, so that we would have configured those helper classes. If you want, you can change the color, whatever, drag it across. So that's removed from our list. But also, if you go back to our server, and if you do a refresh on the server, you'll see it's also gone as well. Okay. So just to talk a little bit about where we would make these calls. So we would have covered this in the previous section, but if we could, for argument's sake, if we look at our report, right, in our report view model, here we are, here's our load, there we are, donation manager, that find all, so that triggers the list, okay, which is in our report view model. Okay, so if we go back and if we just look at our report fragment, I'll expand that for you. Okay, so in our on create view, all right, here we are binding to our report view model again, and if you notice, we really haven't changed. It's exactly the same. So this kind of highlights the benefits of the MVVM. So we've changed the view model, but the actual view hasn't been affected at all. All we're doing is we're still just retrieving the same information through that render. So when we call our render, we're just displaying, if we scroll into our render, I think it's down here, is it? There we go. Okay, don't worry about those errors there. It's just whatever way it's after loading up for me. All right, so this is exactly the same as what we had in the previous examples. The major changes we've made is back in our report view model, so which is here, which is the previous example. We were retrieving kind of from the raw list itself, whereas now our find all is making those requests. So again, let's have a look at our donation manager. Just clap these down again. If we look at our, where are we gone? There we are. Our donation manager, just expand that for you. Okay, so here's the find all, which is inside the donation manager, which in turn is creating and making these anonymous callbacks to get the information from the server. So when we say call.onQueue, it will automatically trigger that. What we've called function, obviously find all, that will trigger this call here, which will then go off and retrieve our data as necessary. Okay, So it would be, if I can collapse those down. So we have our find all, there's our find by ID. Still haven't kind of looked at that yet. We have done the create, so there's with our donation wrapper. And we have done the delete, which also includes the donation wrapper. So just be careful of that. So it could be no harm if when you're working with the delete and with the create, just keep track of your logs. And actually, while I'm here, if I actually look at the log count myself, if I open it up, I have it there. Let me see. I suppose it's gone again, is it? Oh, there we are. It took a little bit of time to catch up there. So if I drag that up a little bit, and if we run through there now, let me see, we'll scroll back up. There's a couple of timeouts there actually, probably not great. Might need to check that. But if we look at our, where are we going? There we are. There's our report view model. Look, the delete was successful. So whatever those timeouts are to do, they're after the fact. Okay, there was our delete. Actually, what's that called? So I can actually do a search. So if we do retrofit, so if we just search for retrofit. So here's all the retrofit messages that we were getting back. Okay, so look, there's the initial load success. There's the JSON getting pulled back. You can see it there. That's that full JSON list. You can see it there. So a lot of information that Timber is thrown back to us there. But the most important bits, I suppose, for us, look, successfully added, successfully deleted. That's what's coming back from the server. That's the JSON information we're getting back, and then we just parse it on the client side. Okay, so look, you got obviously a bit overkill on the Timber statements there. So if you want to, you could actually go through and maybe reduce those, maybe take them out altogether if you want, and maybe kind of display some information back to our messages back to the UI or the screen to give some feedback to a user. But again, this is just kind of for testing purposes. We're just demonstrating how to use retrofit in a particular app. Okay, so in the next example, in the next version, we will move away from the single user, and we'll have a multi-user implementation using our Firebase authentication. Because at the moment, if I go over here again, someone else could have donated the 321, but over here I could delete that one. Even though I may not have deleted, this is what I'm pulling down from the server, so I can delete all those at will, as they say. Okay, so look, again, any questions, any issues, you can contact us over Slack or email. Okay, so hopefully you won't have too many problems with the lab, but we will be online for that lab case for when we're working through the lab at that point in time. Okay, so look, thanks for listening, and goodbye.